Alright, so we are back with some more NBT questions, the second 10 questions from 11 to 20. Okay, so we have if tan theta, so oopsie, tan theta equals 3/4, and theta is between 0 and 90 degrees, then cos theta minus sine theta equals what? Okay, so let's draw a cos diagram here, and we have here it's 180 minus, 180 plus, and 360 minus, and we've got cost. Okay, so what we want to do is we want to figure out, so tan theta we see here is positive, 3/4 is positive, so tan is positive in these two quadrants. Sorry, that's negative, my bad. So tan is positive in these two quadrants, and theta must be between 0 and 90, so that's this quadrant, so we have to work in this quadrant. Okay, so let's just get rid of some of that. So we know which quadrant we have to work in, that's this one, so we can draw our triangle there. We've got our angle theta, and tan is opposite over adjacent, and then we use Pythagoras to find this missing side. Alright, now once we've done that, the rest of the questions are pretty straightforward. Okay, so we want to work out what is cos theta minus sine theta. Okay, so cos theta is adjacent over hypotenuse, so that gives us 4/5 for cos theta. And then sine theta is opposite over hypotenuse, so 3/5. And 4/5 minus 3/5 gives us 1/5. There is our answer. Great, so that's number B. Okay. Question 12. Which of the following is false if theta is between 0 and 90? Let's just write that down. So our angle is between 0 and 90. And now which of these is false? Okay, so what we can do is we can work out each one of these. And let's draw, we probably need our cos diagram in this case again. Okay, and let's write down our 180 minus and 180 plus and 360 minus. Okay, so sec, let's do it like this. Let's write I. We've got sec of theta minus 360. Theta minus 360. So we know sec is 1/cos, so that's 1/cos of theta minus 360, which we can say that's the same as 1/cos of, let's take out a negative, and then it becomes 360 minus theta. Oops, like that. Okay. And what we can do here is we can take this negative to the front, so 1 over negative, or let's keep it actually, what do we want to do? Let's take it out, so negative cos, and then 360 minus theta. Okay. And that finally gives us 1 over, and then cos of 360 minus, cos is positive here, so that's just negative cos theta. Okay. And yep, that should work. So let's just make sure. If we have theta minus 360, so that's the same as having, like, let's say if theta was 30 degrees. If we had 30 here, and we subtract 360, so that's going this direction. Then we get back there. Okay. So minus 360. Am I talking sense or nonsense here? Let's just make sure. Let's do this. Let's get a calculator out and just check what we're doing to make sure. Okay, so let's say we've got cos and we've got 30 minus 360. What will that give us? That gives us 0.86 something. Okay. And if we had cos of 360 minus And so what is negative cos of 360 minus 30? That gives us negative. Okay, so we won't have negative cos actually. We'll have positive cos here. So that makes sense, because we see if we go from here and we take minus 360, we get back into the positive quadrant here. So this won't be negative. And the reason for that, in case you didn't pick up on the mistake here, if we have cos of negative something, cos of negative some angle is the same as cos of positive some angle. So this will just be 1 over cos theta. Okay, so 1 over cos theta is okay, so 1 over cos theta, is that the same as negative sec theta? No, because 1 over cos theta is equal to sec theta. Okay, so this first one is not true. Not true. Then, what does the second one say? Second one, we've got sec of 180 of theta minus 180. So again, that is 1 over cos of theta minus 180. And again, that's the same as saying 1 over cos of negative, and then 180 minus theta. So theta minus 180 or 180 minus theta, it's just, if we add, let's do this again. Let's do this again. I think visually it might actually work out quite nice to look at it. So visually, if this was our theta, let's just call it theta instead of 30. So if we take this minus 180, so that'll be over here, and cos is negative here. Okay, so that would be fine. So we will have 1 over cos theta again. So 1 over cos theta, which is the same as sec theta. Okay, and is that the same as sec theta? Yes. Okay, so the third option we have, let's just erase our visual again so we can find it and draw it from scratch. Okay, so sec of theta plus 720, so that's just 2 revolutions. So that's the same as 1 over cos theta plus 720. Okay, so theta plus 720, so that's 360, 720, so that's still positive. So that's still 1 over cos 720, or just cos theta in this case, which is the same as sec theta. Okay, so it's not negative sec, it's positive sec. And then finally sec of 180 minus theta for the fourth version. So sec of 180 minus theta. So that's the same as 1 over cos of 180 minus theta. And now if we have cos 180 minus, so cos 180 minus, we know that's negative, cos is negative there. So that's the same as 1 over negative cos theta, which will give us negative sec theta. Okay, so that is negative sec theta, yes. So these two are correct. So 2 and 4. There we go. Great. So quite a bit of work to do to find all the possible options, and there are quicker ways, shortcut ways, but I just wanted to go through it fairly slowly. Alright. Then we get this triangle. In triangle PQR, cos R. Okay, so cos R, it's not a right angle triangle, or at least we can't say that it is. It might be, but we're not told that, so we can't assume that. So we'll have to use the non-right angle triangle formula for the cosine of R. So we know that this side squared, let's do that. So 2 squared equals the other two sides squared added together, squared, minus 2 times the other two sides, times the cosine of the angle opposite this one, cos R, which we want. And now I want to get cos R by itself. So we can go 2 squared, minus the 3 squared, minus the 4 squared, and then what's left is this whole part. So then we want to divide this part away. So divided by -2 times 3 times 4, and that'll give us the cosine of our angle. Okay, so let's work this out. So 2 squared 4, so it's 4 minus 9 minus 16 over -2 times 3 is 6 times 4 is 24. And let's simplify that a little bit more. So 4 minus 9 is -5, minus 16 is -21 over -24. And we can divide both of these by -7, so we get, no, we cannot, by -3, sorry. So we get 7 over 8 equals cos r. And is that one of the options? Yes, what a bargain. Good, so there we have it. Then question 14, a tangent to this circle. So we've got the circle x squared plus y squared equals 25, and what that means is we have a circle with a center of the origin, because our standard circle formula is x minus a squared plus y minus b squared equals r squared. Okay, and in this case, if we have this, then the center of our circle is the value opposite of that sign for the x value and opposite of that for the y value. In this case, so it's x minus 0 squared and y minus 0 squared. So our center would be 0, 0. And then our radius squared is 25, so our radius would be 5. Yeah, so let's say radius equals r. So in our case, center is 0, 0, and the radius is 5. So that'll be 5, 5, -5, -5. Okay, we'll go through the point, which of these points. So what you can do is, we don't even actually need to know this for this question. We can just substitute values, all these values, and see which one gives us a true value. And it will be this one if I look at it quickly. And let's see. Let's just do one first that I think will not work. This one. Okay, so if we choose that one, then we'll have x squared plus y squared equals 25. So this will give us 9 plus 49 equals 25. So 58 equals 25. No, that's not right. So this won't work. And then we can just do the same for all of these. So this will be exactly the same value. This will also be 58 equals 28, which is wrong. This one will give us 9 plus 25, 34, which is not 25. This one should work. -3 squared plus -4 squared equals 25. So we'll get 9 plus 16 equals 25, which is 25 equals 25. Yes. So here we go. That's the right one. And this one will give us the same value as that, which is again wrong. Alright. Good. So question 15. Which of the following circles have the same midpoint? Okay, so midpoint, I'm assuming it's the center of the circle. So we have x minus a squared plus y minus b squared equals r squared. And now these values, they will, if they are the same, then the center of the circle is the same. So the let's call it M for midpoint of the circle, will be A, B. Okay, so we need to somehow get these equations to look like this. So let's see what we can do. For equation 1, so for this one we need to do completing the square to get it in this form. So let's just rewrite it all the x's together. So x squared plus 4x plus y squared minus 6y equals -4. Okay, so we need to do completing the square. So for completing the square, the value in front of the x squared must be 1. So it is already 1, so we can just rewrite the first two terms. And then we add this value over 2 squared. So 4 over 2, which is just 2 squared. And we also want to add it to the other side. So plus also 2 squared here. Then we can do the y's. So we've got y squared minus 6y. And we add to that this value over 2 squared. So -6 over 2 is 3 squared. And we add the 3 squared to this side. You could put negative if you want inside, but that doesn't really make a difference. Okay, and the reason why we do that for completing the square is so that both of these things now are a perfect square. So we can say this gives us x, that sign, and what's in the bracket, squared, plus, and then we can do the y's. So we've got y, this sign, and what's inside the bracket, squared. And then we can just work this out. In this case, we won't even need this side, but let's just work it out anyway. So this gives us 4 plus 9 is 13 minus 4 is 9. Okay, so in this case, our midpoint will be -2 and +3. So that's the midpoint of the first circle. So let's do the midpoint, find the midpoint for each circle and see which ones are the same. So that's circle 1, or equation 1. For equation 2, we can just read this one off, right? For equation 2, let's do that. We can just read that off, so that'll be -2 and +3. So our midpoint will be -2 and +3. So far these two are the same. For the third circle, third equation, our midpoint would be +3 and -2. So it'll be +3 and -2. So that one is not the same. So let's do those two are the same so far. This one is not. And then for the fourth one, we have, oh no, it's just the 3. Okay, so it'll be number 1 and number 2. So 1 and 2. That's right. Someone's already circled the right answer there. Perfect. Alright, question 16. A ladder of length 20 meter and midpoint P stands vertical against the wall. The bottom of the ladder is pulled away from the wall, whilst the top of the ladder stays in contact with the wall at the time. The locus of point P is illustrated by which graph? Okay, so let's see this. And midpoint P. Okay, so if we have, this is our wall, this is the ladder. So midpoint P. Okay, now imagine, okay, I'm gonna do this. I'm just gonna draw a couple of lines here. And like that, and like that. Okay, so what we're gonna do, and let's put in the value for P, the midpoint. So that's P, and that's P. Okay, so just to illustrate what's happening here is we have this line. So far P's moved from there to there. Okay, then we do this one. Then we see, so P's moved like that so far, and then in this one when it's quite flat, should probably, this is not a good line. But this is unfortunate. I'm not that good at drawing. Maybe I should do it a slightly different way. Okay, I'm just going to erase these ones and work from here. Okay, but you can already see the idea. So here, so it remains in contact with the wall, and now the bottom slides out a little bit further. So now the midpoint is here. Then we can go a little bit further even, and then the midpoint is here, and then we can go even further, and and the midpoint will be somewhere here. So this idea. Now the problem is, we have to sort of think about, so it's either going to be, so we see the thing goes down, so it's either going to be this one or this one so far. So now we just need to think, does it go down in a straight line, or does it move a little bit? So what you can do, I think, just take if you've got a corner in your room of a wall, just take a ruler or a pen or anything, put it against the wall, and then just sort of move it, hold it in the middle, that your finger will be point P, and as you slide it down, just see what you get. Do you get a straight line going down, or does it look more like a hyperbola? So I'm gonna say it is this one, but go test it out for yourself and see if it makes sense. Alright. Now for which values, question 17, so 17, 18, 19, 20, 4 more to go. So for which values of x is this equal to 0? Well, the nice thing here is we know that 0 divided by anything equals 0, right? So all we need to know is that the top will be 0 and the bottom will not be 0. Because if we're dividing by 0, that's undefined. Okay, so if the top is 0, we can just say x minus 2 times x plus 1 must be equal to 0 for this to be true. 1. Okay, so that means x must be equal to 2 or x must be equal to negative 1. And we know that because of this, x minus 3 cannot be 0 because we cannot divide by 0, so x cannot be 3. And x isn't 3 in any of these examples, so this doesn't even matter. So if x is 2 or x is negative 1, this answer will be 0. Great. So in essence, we just have to say the top must be equal to 0 for the whole thing to be equal to 0. Great. Then we get to the third last question. If a is less than b, if a is negative, so a is negative, b is 0, and c is positive, the roots of this equation, ax squared plus bx plus c equals 0 are always, okay, so the roots of those equation, that will be the roots, we have negative b plus minus square root of b squared minus 4ac over 2a. Okay, so we can just substitute these with positives and negatives and see what we get. Okay, so x equals, so negative b, so b is 0, so that's just 0, plus or minus, 0 squared is 0, minus 4, and a is negative, and c is positive. Okay, divided by 2 times a, which is negative. Alright, let's see what this gives us. So 0 plus or minus, so we can just have plus or minus. What about this part? So we've got a minus and a minus together, which makes a plus. So we've got 0 plus 4ac, so we've got 4ac, and that is a positive number. So all we need to do is say that's a positive number. And at the bottom we've got a negative number. Okay, so let's see what we can get. So we've got either positive some square root and over a negative, and this will give us a positive divided by a negative is a negative, or we've got negative of this some square root over a negative, which will give us negative over negative is a positive. So we can have a negative or a positive, but it will always be real. That's it. Okay. So that's the most we can get out of it. To be non-real, we would have had to have a negative in here, then we would have had b. For rational, we would have had to have a perfect square underneath the square root, and we don't know if we've got a perfect square, because all we know is if it's positive or negative. Irrational, we don't know that either, again, because of the same reason we don't know if it's rational. And it won't be 0, because if it were 0, the top would have had to be 0. But it won't be because we've got a negative and a positive number multiplied together, which won't give us a 0 necessarily. It's a possibility, but actually no, it's not a possibility, so it won't be 0. It's real. Alright, second last question. So we have, let's do a blue one. Simplify this. Okay, so we've got 2 root 8 minus 4 root 32 plus 3 root 50. And here is where prime factors come to the rescue. So 2, and then inside the root, 8 is the same as 2 cubed, minus 4, and 32 is the same as 2 to the power 5, plus 3, and then 50, let's see, 50 is the same as 2 times 5 squared. Now let's just recap how we get these values. Let's do 50 as an example. So we find, what's the first prime number that we have? 2. Can we divide 50 by 2? Yes, then we get 25. Can we divide 25 by 2? No. Can we divide it by 3? No. What's the next prime number? 5. So 25 divided by 5 is 5. We can divide it by 5 again. So we get 2 times 5 times 5. So that's 2 times 5 squared. Alright. Now, we can say a couple of ways we can think about this actually. And what I like to do is I'd say 2. And then we can see here. So it's a square root, so there's an imaginary 2. So what is 3 divided by 2? That's 1. So we can take out in brackets, or not in brackets, in quotes, we can take out a 2 to the power 1, because 3 divided by 2 is 1. And what's the remainder? The remainder is 1, so there remains a 1, 2 inside. Okay, minus 4, here again, 5 divided by 2 is 2, so we can take out a 2 to the power 2, and the remainder would be 1 again. Then 1 divided by 2 is nothing, so we can't take any 2's out. But 5's, 2 divided by 2 is 1, so we can take a 1 5 out. And what's left inside, no 5's are left, because 2 divided by 2 is 1 with no remainder, but there's that 2 still left. Okay, so 2 times 2 is 4, and 4 times 2 squared, so 4 times 4 is 16, and 3 times 5 is 15. So we've got like terms because it's 4 root 2's minus 16 root 2's plus 15 root 2. So we can just add all these together. So 4 minus 16, negative 12, plus 15 is 3. So we've got 3 root 2's. That is simplified. Alright, and then our final question for this video. Ooh, what does this equal? Now this is quite nice because your calculator probably won't be able to give you this anyway, because calculator screens can only handle so much data. So this is where mathematics and thinking about things properly come into play. 2 to the power 15 plus 3 to the power 2015. Okay. So what can we do here? Well, we can't figure out each value because we'll be spending our whole lives just doing 3 times 3 times 3 times 3 2015 times. So that's not going to help us. But what we can do is we can think about it in two different ways. One is to say, let's factorize. So we can take out a common factor of 3 to the power 2015. And then what's left is 1 plus 1 plus 1. And that is 3 to the power 2015 times 3. And then if we're multiplying and the base is the same, then we add the exponents. So 2015 plus 1. So that gives us 3 to the power 2016. And that is our answer. Another way we could have thought about it, which a lot of you probably did, is say there are 3 of these things. So that's just the same as saying 3 times whatever this is. Like just if we had x plus x plus x, we could say that's the same as 3 times x. So now we can say we've got 3 of these things. So 3 times 3 to the power 2015 equals 3 to the power 1 plus 2015 gives us 2016. So there is our answer. 3 to the power 2016. Good. And that is it for this video, and I'll be uploading some more shortly.